Let's talk about immutability in Dart. Sounds boring? Well, don't leave right now. Boring code is easy to understand and easy to fix. With immutable data structures, your code becomes easy and predictable. And if you care about reducing bugs in your apps, boring code is exactly what you should be aiming for. After a quick introduction into immutability, I'll show you a bug from a real-world application. This bug costed at least 3 days of a sprint, and it could have been prevented in the first place by using immutable data structures. After this talk, you'll understand that immutability should be the default, like in many other languages, and how to achieve this in Dart. All of you have already used immutable objects. Primitives like integers, boolean and strings are immutable. A 7 is always a 7, you cannot mutate it. Additions don't mutate the terms, they create a result and a new immutable object. There are not only primitives, you can also create custom immutable classes. Flutter Widgets, for example, stateless and stateful are both immutable. A widget is an immutable blueprint to construct and update an element in the element tree. Widget properties are final and can change once the object is created. We can compare widgets from the previous and the current frame in the didUpdateWidget method of our state. When we detect changes, we can trigger animation controllers to gradually interpolate between the old and the new value over the next few frames. Widgets with mutable properties wouldn't work. The old and the new could be the same instance, and then we couldn't detect what has changed. Let's jump right into code and create our first immutable class.
My name is Pascal Welsch and I'm a Google developer expert from Germany. You can find me on social media with the handle @Passi with triple S. I want to show you how to create an immutable object in Dart in code. We want to build this application today where we can see pictures of Dash available for purchase. Some of them are featured, some aren't. So first of all, let's create an immutable object which holds the values for a single item. I call this my product and it has a name, a price, an URL and a featured flag if it's featured or not. What's missing here is the constructor. So I use IntelliJ to generate it. The same works for VS Code. This class has only final fields and a single constructor. Nobody is able to change the properties after it was instantiated. So this is a truly immutable class in Dart. We can use it like this. So here I create two different products. One is named Gopher, the other is named Dash. And now I create a list of products. With that list of products, I want to show you how you can change properties by creating copies of the immutable object. So as a fun little task, I thought that we want to feature birds. So whenever there is a product which contains the name Dash, it will be featured. So let's call that function. It's called feature birds and I pass in my products list. So it will now iterate over all the products and when it contains Dash, it will create a copy. It calls a new constructor, it creates a new immutable object. It receives all the properties the object has and sets the feature flag to true. If Dash is not part of the name, it returns the object as it is. So if I print the output here, or better, I set a breakpoint and I run that code. So now you can see the beauty of immutable objects. We can now check what was the input. Oh, both are false. And what's the output? Dash is true. Let's hope the other one is false. Yes, it is. So the beauty of immutable objects is that they are not mutable. They do not change while a function is executed. And you can very easily compare what goes in and what goes out. So you know what an immutable object is, and debugging is rather easy. But there's one thing we can improve. In our debugger, if we only look at the list, we only see my product. So definitely the toString method is missing. We can generate it as well with IntelliJ and pick all the properties we want to show in the toString method, run it again, and now it's even easier to compare what changed. We can go a step further. There's a plugin called Dart Data Class, and it allows us to generate all of that stuff for us. So I will generate this here, and it generates a lot of code. At the top, a constructor, we had that as already. A cool copyWidth method, we will use that in a second. The toString method and correct equals and hashcode implementation. Also, it generates a toMap and a fromMap constructor. We can use that to serialize the object. I rarely use that, but yeah, it's there. So let's use the copyWidth method, because in our featureBirds method, we were manually creating a new instance. The problem is here, if a new property gets added, we probably forget adding it here as well. Instead of those lines, I will return product.copyWidth and only change the featured flag to true. That's way easier and future-proof. It's also way easier to read. This plugin is available for VS Code and IntelliJ from different authors, but they do essentially the same thing. Right now we have immutable items here, or immutable objects, but the list in Dart is always mutable. And I show you a diagram for this. So in Dart we have list, set and map. All of those base collections are mutable. You cannot create a list or an immutable list by default. You always create a mutable one. If you use the default constructor to create a list in Kotlin, you create an immutable list. The same for set and map. You have to explicitly say this has to be mutable, and you then get a mutable list. So there's a bit of difference, but all the modern languages kind of go with that pattern, that by default everything is immutable. Dart is a bit older, doesn't have that feature. But I personally ported the collection library from Kotlin over to Dart so that we can use immutable collections as well. And I will show you why and how. Previously I showed you that debugging is now easier and it's easier to understand what happened. But look at this. I can now call products.remove dash. And if I print the products and add a breakpoint here, it's rather confusing because initially I had one product and then I called featureBirds and now I have two products. What's going on here? This shouldn't happen. The problem is that we can actually remove an item from that list. So it would be better to have an immutable version here. I already imported the kt.dart library. It's a port of the Kotlin standard library and contains the collections, the immutable collections and mutable collections. So let's replace our list with a kt list. We only have to call the kt list constructor of, and now we have an immutable list. I have to change the implementation of the featureBirds method because now it accepts the immutable version. There's a slightly difference, so map actually returns a list and not an iterable. And there is no remove method. It's not because it's called differently. No, KT_list is an immutable list. It doesn't offer any mutable functions. The only way you can mutate it is by calling toMutableList and then remove. But toMutableList will return a new list. So you have to keep track of that. And if I debug it now, everything should be fine. Yes, we start with 2 products and we end up with 2 products. One of them is featured, the other isn't. And our mutable list has only 1 item and we can use it for whatever we want. So this is how how you should handle immutable lists by using a library. There are other libraries as well, like build collection from Google. It's rather old, but it works. And it works like this. So you can create a collection and from there you have an immutable list. It works also together with build value, which is a generator to generate immutable data classes, similar to data classes in Kotlin. Besides build value, there's another cool library called Freest. Freest is by Remy, who also created Provider, and I use it since day one. And I will show you what it does. So currently we have been using the my product, but I already created a product with the same properties, but with Freest. Let's look at the implementation. This is how a Freest data class looks like. You define a const factory constructor, define all the properties, and then you define a name for that class. You can come up with everything because this is then auto-generated by the code generator. So if you define it like this, the code generator runs and generates all that stuff. It also creates a copy with method, and this is special, and this is one of the features why I immediately switched over to Freest. The problem with the copy with method we previously generated is that the implementation looked at the value of null. If the value is null, which is the default value, it was using the default value of that property. So let's see the difference. This is the Freest implementation, and I print B here. And what we will see is that, let's run it. Featured is true, image URL is null. If we run the same code for my product, I have to change it to my product. The code is the same, but we have a different implementation of the copy with method. If I run that one, let's run it like this. So now this is the product, and although we changed image URL to null, it's still to do. And that's because of the implementation. It checks if a property is null. If it's null, it uses the existing property. The implementation of Freest is a bit different, and it allows us to set properties back to null. Whenever you talk to different systems, this could be a server, this could be a platform channel. If you pass over a message when creating a Flutter plugin, you should always use immutable objects, because the objects you receive as well as the objects you send are basically immutable. If you change a property there, it will not change that property in another system. So most of the time you really should use immutable objects for communication with other systems over the network, or inter-process communication. If you start an isolate and send or pass an object over, it should be immutable. Let's talk about the problem we encountered in a real-world application. And we solved it by going to immutable objects. Let's see our application. So we have a list of products, and you can already see 6 products. We have 2 screens. We have one screen to view all products, and this was in the app for a long time. The new screen, the best sellers, we're only showing the featured products. That's why we have this featured flag. So in this screen we see this is featured as well as that one, but those 3 aren't featured. So when we created that screen and featured products are red here, we only see those 3 products. The problem is now that if I go back to the all products screen, I also see only the featured products, and that's a big problem. And we did not understand how this is possible. Actually, it really depends on how the user navigates through the app. Sometimes they see all the items and sometimes only the featured items. So let's look at the code and figure out what's wrong here. So first let's look at the all products page. In our app we have a so-called shop model. It's a model which sits on top of the application and it loads data from an API. When the model is created at the beginning of the app start, it calls the API, gets all the products and notifies all the listeners. It's a change notifier and I integrated it with provider. In our real world application we actually use block, but the concepts are more or less the same. So whenever I use watch here to watch the change notifier, whenever notify listeners is called, this whole widget will be rebuilt. So I always receive the updated model here. I get the products and I use the product grid, which is a widget showing a grid of products. So not much logic here which could go wrong. Let's look at the screen for the best sellers. It's called a featured products page and it looks like this. So we also get the model, we get the updated model every time, we get the products, we remove the items which are not featured and then show the products. So in this screen we only see products which are featured. Pretty straightforward. So where's the problem? The problem is that if a user visits this screen, remove where is called and it removes items from the list. The list is actually shared between both screens. And if we remove items here, they are also removed in the other screen. And this was pretty bad because we had not touched this screen. We only worked on the other screen and somehow it caused an error in a different part of the application. Pretty bad, we did not catch it, we released a faulty version to the end users and nobody was happy. So how can we solve that problem? Before we can solve the problem, we have to find it. So where can we start? Looking at the load product function gives us not much information. It loads the products and prints 6 all the time in the log. We check that it's always 6, nothing changes. It's not a problem from the API, it's our problem. What's interesting here is that this model exposes the list we got from the server. It exposes the mutable version of it. So everyone with access to products is able to add and remove items from that list. We haven't designed it like that. It was by accident. We only want others to read the products variable, but they can do whatever they want because the list is mutable. To change that without additional libraries, we could call the toList function with growable false. This is the equivalent to list.unmodifiable, like this. So now we create a copy of that list. Whoever receives that list can mutate it, and the others will not get the updates as well. In the default version, we return an unmodifiable list. This also means that whenever someone tries to mutate it, for example, call delete or add on it, it throws an exception. Let's try that out, and I'm pretty sure we will see a red screen somewhere. So let's start the application again, and first go to this screen. All looks fine. Go to the bestseller screen. Yes! There we have our crash. Cannot remove from a fixed length list. This is the fixed length list. It's not growable. We cannot add an item. So we now pinpoint down where the problem is. It's caused by products.removewhere. Removewhere does not only change the products in this variable, it also changes it in model.products because it's the same instance, the same reference. To change that, we have to create a copy in here. We create a toList. This is now by default a mutable version. And if we run it again, we see, oh yes, we only have 3 products here and other products here. Calling toList here is unexpected. We do not exactly know if this list returned here is modifiable or not, because in Dart we do not have the distinction between a mutable and an immutable list, unlike in Kotlin. So how can we improve this? Because I'm still able to call remove on the original list, which is immutable, and this results in a runtime exception. And that's not a good way to design APIs, because people expect methods to work if they are part of the public API. So how do we solve this? Instead of using the standard list of Dart, we can use the KT Dart list. It's rather easy to change this. So here, let's change it all together. So remove this here and return the KT list dot empty in the default case. Oh, we have to change this one here as well. Let's change everything to KT list. This looks fine. So now from our API we get a normal Dart list. So we have to convert it to an immutable KT Dart list. There's an extension function for that. It's called toImmutableList. So whenever I receive a list from somewhere and I want to have it immutable, I call this extension function toImmutableList, and it will convert the list to a KT list. The API of a KT list is slightly different, so we have to adjust it at some points. For example, here we have to show the size. And this is an example where in our business logic, we definitely want to work with immutable data types. But in Flutter, it is very common to use just lists, because these are part of the Dart SDK, and you do not have to have an external library. So on a view layer, on a widget layer, working with lists is okay. It's rather easy, and especially in the declarative way we write our build methods, it's easier to read if we write a list like this compared to KT list dot empty. So we want to continue using pure Dart lists in our widgets. To do that, we can convert the list back to a pure Dart list. And can it be null? Yes, it can be null as list. Actually, it cannot be null. No. Yeah, we call the function as list, and this converts the KT list back to a normal list. I think we have to do the same now for the bestseller page. And here we have to do a bit more work. So we get the products here, but we really want to remove the not featured products. So I filter the list with the same code I wrote earlier. And I think that's it. Converting this one as well as list. Yeah, that was correct. That's it. Let's run our app again and see if everything is working. Restart the application. We load 6 products here and we load 3 products here. So far everything is fine. Now if we go back, we should see all 6 products here again. Yes, yes. And the best thing about using immutable lists or a real immutable list interface is that nobody can screw it up. So I cannot remove something, I cannot add something to this immutable type. It's really safe. I showed you how to break an app by sharing mutable properties within the app and mutating it without telling someone. I showed you how to prevent it by using immutable data types, an immutable list, so nobody can mutate it unless you really want someone to mutate it. Let's talk again about our freeze class, because the freeze library has so many more features you may want to use. This is the freeze package, and I want to show you 2 cool features which I haven't used right now. So right now we only used creating data classes using freeze, immutable data classes. And another cool thing is that freeze only supports immutable classes. If you're coming from Kotlin, Kotlin offers data classes with mutable properties. Freeze doesn't. Everything is immutable here. If you create a freeze class in your project, you are sure that no one of your colleagues will add mutable properties there. So it's very safe. A big problem of immutable data types is that if you want to change a single value deep in a tree of an immutable data structure, you have to copy a lot of things. In this example, we have a company, and the company has a director, and the director has an assistant. And if we want to change the name of the assistant, we have to write a lot of boilerplate code to copy that one property. Freeze solved that with code generation, and it generates us a cool new API, which I haven't seen in other languages. So we can call company copy with, and instead of executing the copy with function, we can continue calling director.assistant and then change the property of that assistant. The assistant method here will return a new instance of that whole tree, of that whole object tree, and we have a new company, a new immutable object where only one property very deep down is changed. Another great feature which exists in Kotlin is sealed classes. Basically enums with properties, and every enum value can have different properties. It works like this. You create a union, for example, for a state where you want to show this is the value, this is when the state is loading, this is when it has an arrow. This is pretty common in most apps. We can create a freeze class with 3 constructors, and under the hood it creates 3 different types. All of those implement the union interface. This is a great way to model your app logic or your domain logic if you're thinking about domain-driven design. So all those states have to be handled. Whenever you receive a union object, you have to handle all those 3 states, or more if you add more constructors. One way to do this is with the when function. You call when, and then you have to define some kind of logic how to handle it for each of those cases. And it's guaranteed that you handle all those cases, because the when function is auto-generated. If you add a new constructor, it will also add a new property to the, or a new argument to the when function. If you care about immutable objects in your project, you definitely should add freezed. There are some other libraries, but freezed is by far the most elegant one. If you have any questions after this talk, feel free to contact me on Twitter and I will respond as soon as possible. Have a great day.